Hello there. Welcome to Lesson 3.2. We just learned that parallel lines are coplanar lines that never intersect. Kind of like the lasers that I occasionally shoot out of my eyes. Woo! Anyway, let's talk about some properties of these parallel lines. Okay, so there are special angle pairs formed by parallel lines and transversals. And remember we talked about transversals intersecting two lines. Now, if those lines are parallel, then we get all these special relationships where some of them are congruent, some of them are supplementary. Maybe they're both, depending on if the transversal is perpendicular to the two lines it's intersecting. So, if a transversal intersects two parallel lines, this is, by the way, this is postulate 3.1, same side interior angle postulate. If a transversal intersects two parallel lines, then same side interior angles are supplementary. So, if you have two parallel lines and they are intersected by a transversal, same side interior angles are supplementary. So that means that the measure of angle 4 plus the measure of angle 5 is going to equal 180 degrees. And also the measure of angle 3 plus the measure of angle 6 is going to equal 180 degrees. That's pretty cool. So, the way I said it when I was in school back in the day, two parallel lines cut by a transversal, then same side interior angles are supplementary. Alright, how are we going to use this information? Alright, so the measure of angle 3 is 55 degrees. So this guy right here is 55 degrees. Which angles are supplementary to angle 3? And how do you know? Well, it looks to me as though angle 8 would be supplementary. Let's see how we do this. By definition, a straight angle measures 180 degrees. So, this is one of the first ones we learned. Straight angle is 180 degrees. What else do we know? If the measure of angle A equals plus the measure of angle B equals 180 degrees, then they're supplementary. So those are the ways that we know. So any angle, 180 minus 55 is 125. So any angle where the measure of angle x is 125 degrees is supplementary to angle 3. So the measure of angle 4 is 125 degrees. It's supplementary to angle 3 because this is a straight angle. Measure of angle 8 is 125 degrees because the measure of angle 3 and the measure of angle 8 have to add up to 180. So 3 and 8 are supplementary. And then measure of angle 6 equals the measure of angle 8 because they're vertical angles. Let's see, what else? Measure of angle 2 is equal to the measure of angle 4 because they're vertical angles. So, what are all the supplementary angles? The angles are, let's see, we got angle 8, angle 6, angle 4, and angle 2. Those are all supplementary to angle 3. So let's see if we got it. Pause and see if you can answer this question. Alright, so if you know the measure of one of the angles, can you always find the measure of all 8 angles when two parallel lines are cut by a transversal? Well, let's see. I know that we got 55 for angle 3. That means we got 55 here, vertical angles. This was 125, and then vertical angles says 125. 3 and 8 are supplementary, so that's 125. 8 and 7 are supplementary because they are a linear pair, so 7 is 55. 8 and 6 are congruent, so 6 is 125 degrees, 5 and 7 are congruent because they're vertical angles. That's 55 degrees. So yeah, if we know one of the angles, then we know all of the angles. Bada boom, bada bing, bada bang, bada boing. Alright, theorem 3.1. The alternate interior angles theorem. If you got two parallel lines cut by a transversal, then alternate interior angles are congruent. So if you got two parallel lines cut by a transversal, alternate interior angles are congruent. So that means angle 4 is congruent to angle 6 because they're on opposite sides of the transversal and interior between the two parallel lines. And angle 3 is congruent to angle 5. Alternate interior angles are congruent. Theorem 3.2 is corresponding angles theorem. By the way, these theorems should be in your notes. You're going to use these a lot. Corresponding angles theorem. Two parallel lines are cut by a transversal, then, so here's two parallel lines cut by a transversal, then corresponding angles are congruent. So 1 and 5 are in corresponding positions. They're both top left. So angle 1 is congruent to angle 5. Angle 2 and angle 6 are both in top right position. So angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. They're both in bottom right position. And angle 4 is congruent to angle 8. Those are both in bottom left position. Necktie. That is your secret phrase. Okay, let's prove this. We're proving theorem 3.1. I like it. So we are given that line L is parallel to line M. And we would like to prove that angle 4 is congruent to angle 6. Alright. Well, shoot, where do we start? Well, where do we always start with a proof? We start with what we're given. So we are given that line L is parallel to line M. Well, let's see, what else do we know at this point? I think the fact that angle 3 is labeled is probably a hint. So what do I know about angle 4 and angle 3? Let's see, they're a linear pair. Is that going to help me out? Maybe if I can show that angle 4 is supplementary to angle 3 and that angle 6 is also supplementary to angle 3, then angle 4 and angle 6 got to be congruent because they both are supplementary to angle 3. So angle 4 is supplementary to angle 3 because the measure of angle 3 plus the measure of angle 4 is 180 degrees, and that's the definition of supplementary angles that you get from a linear pair. The measure of angle 3 plus the measure of angle 6 equals 180 degrees because of the same side interior angles postulate. Same side interior angles, when you have two parallel lines cut by a transversal, are supplementary. So what can I do with this now? Well, this sum equals 180, and 180 equals this sum, so I can set the left side of this equation equal to the left side of this equation using the transitive property of equality, because they both equal 180. Let's see, remember what's my goal? My goal is to prove that angle 4 is congruent to angle 6. And the definition of congruent angles is that they have the same measure. Am I pretty close to that? Here I got measure of angle 3 plus measure of angle 4 equals measure of angle 3 plus measure of angle 6. Yeah, 6. I'm pretty close. Here I got measure of angle 4, here I got measure of angle 6. What would I need to do to get measure of angle 4 equal to measure of angle 6? I just need to subtract measure of angle 3 off of each side. And that is the subtraction property of equality. Because remember that the measure of angle 3 is a number. So I can subtract the same real number from both sides of an equation. Once I have measure of angle 4 equal to measure of angle 6, now I can say that angle 4 is congruent to angle 6 because that is the definition of congruent angles. Q, E, D. Alright, problem 2. We are given that line A is parallel to line B. We would like to prove that angle 1 and angle 8 are supplementary. Here's angle 1, here's angle 8. We want to prove that those are supplementary. Well, shucks. Where do I start? Oh, the same place I always start, with the given information. It's given that line A is parallel to line B. Well, let's see. What else do I know? Let's see. We just talked about a theorem that says that corresponding angles are congruent. So I can say that angle 1 and angle 5 are corresponding angles, right? They're both top left position. So angle 1 is congruent to angle 5 because if lines are parallel, then corresponding angles are congruent. Well, let's see. How does that help us? Well, it'd be pretty easy to show that angle 5 and angle 8 are supplementary. Let's see. So we've shown that angle 1 and angle 5 are congruent, so they have the same measure. And then it looks pretty obvious that angle 8 and angle 5 are supplementary. So then we can use that information to show that angle 1 and angle 8 are supplementary. So let's start walking down that path. Since angle 1 is congruent to angle 5, we know that the measure of angle 1 is equal to the measure of angle 5. Congruent angles have the same measures. Definition of congruent angles. Angle 5 and angle 8 are supplementary. We know that because angles that form a linear pair are supplementary. So what does that mean? If they're supplementary, that means that the measure of angle 5 plus the measure of angle 8 equals 180. That's the definition of supplementary angles. Now, what could we do? What's our goal? Our goal is to prove that angle 1 and angle 8 are supplementary. So we want to be able to say that the measure of angle 1 plus the measure of angle 8 equals 180 degrees. Well, right here I have the fact that measure of angle 1 is equal to the measure of angle 5. So I can use the substitution property of equality to substitute the measure of angle 1 in for the measure of angle 5. The substitution property. Now that I have the measure of angle 1 plus the measure of angle 8 equals 180 degrees, well, that's the definition of supplementary angles. So I can now say that angle 1 and angle 8 are supplementary by the definition of supplementary angles. QED! Yay! Alright, pause and see if you can work out this proof. Okay, where do we begin? We begin with the given information. So, we know that line A is parallel to line B. We want to prove that, let's see, so this is the old prove. We're just using the information, the given information and the picture to prove that angle 1 is congruent to angle 7. So these are alternate exterior angles here. Alright, how could we do that? What's going to be our plan? Well, we just proved that angle 1 is supplementary to angle 8. So we could go through all that logic and then prove that since 8 and 7 are supplementary, that 1 would be congruent to 7. But 5 and 7 are vertical angles, and 1 and 5 are corresponding angles. So that might be an easier way to prove it, because 1's congruent to 5 because they're corresponding angles, 5's congruent to 7 because they're vertical angles, and then using the transitive property of congruence, we could say that since 1 is congruent to 5 and 5 is congruent to 7, then 1 must be congruent to 7. I think that way sounds a little easier. So, I'm going to say angle 1 is congruent to angle 5 because if lines are parallel, then corresponding angles are congruent. And then I'm going to say that angle 5 is congruent to angle 7 because vertical angles are congruent. And now I have the setup for the transitive property of congruence. 1 is congruent to 5, 5 is congruent to 7, so angle 1 is congruent to angle 7 by the transitive property of congruence. Got my prove statement, so I'm done. Q, E, D. Ding! So, we've pretty much just proved that alternate exterior angles are congruent. If you've got two parallel lines cut by a transversal, alternate exterior angles are congruent. So that means that angle 1 is congruent to angle 7 and angle 2 is congruent to angle 8. Put that in your notes, kid. Alright, so problem 3. What are the measures of angle 3 and angle 4, and which theorem or postulate justifies each answer? Well, since P is parallel to Q, the measure of angle 3 equals 105 by alternate interior angles. This angle is congruent to this angle, so the measure of angle 3 is 105 degrees. What about measure of angle 4? We got L and M also parallel, so that means that the measure of angle 4 plus 105 degrees is 180 because same side interior angles are supplementary. So if we take 180 and subtract 105, we get that the measure of angle 4 is 75 degrees. So go ahead and pause and see if you got it. Okay, so A, angle 1. Let's see, we got that the measure of angle 4 was 75 degrees. 1 and 4 are congruent because of alternate interior angles. So that means that the measure of angle 1 is 75 degrees. How about angle 5? Well, we've already shown that the measure of angle 3 is 105 degrees. 5 and 3 are vertical angles, so the measure of angle 5 equals 105 by vertical angles theorem. Vertical angles are congruent. Angle 7 is a vertical angle across from this 105 degree angle, so we know that that's 105. Measure of angle 7 is 105, also by vertical angles theorem. Angle 2, let's see, we already said angle 1 was 75. Angle 2 is a vertical angle to angle 1, so we got measure of angle 2 equals 75. And we used the alternate interior angles theorem. And vertical angles. Measure of angle 6. Well, let's see. If we think about L and M being parallel and Q as the transversal, then we got alternate interior angles here. So we got measure of angle 6 equal to 105 by alternate interior angles congruent. And then measure of angle 8. We can say, look, 3 and 8 are corresponding. So that means that the measure of angle 8 is the same as measure of angle 3, which is 105 by corresponding angles are congruent when you have two parallel lines. Problem 4, what is the value of y? Why? So if we think about, we got this line and this line parallel, and then this line is a transversal. Also, this line is a transversal. So different ways to think about this problem. By the angle addition postulate, y plus 40 is the measure of an interior angle. So if we're thinking about this whole angle here and this whole angle here, these two are supplementary. This angle is y plus 40 by angle addition postulate, and this angle is 80. So y plus 40 plus 80 equals 180, because of same side interior angles of parallel lines are supplementary. 40 plus 80 is 120. Subtract 120 from both sides and you get y equals 60. And then you come over here and you bubble it. 60. 60. Alright, see if you got it. Pause it and see if you got it. You can do it! Okay, so what are the values of x and y? Alright, so I got x's over here and I got y's over there. I got two parallel lines cut by this here transversal. So that gives me same side interior angles of 2x and x minus 12. So that means that these two angles are supplementary by that theorem we just talked about. Parallel lines cut by a transversal, same side interior angles are supplementary. So that means that 2x plus x minus 12 equals 180. So 2x plus x is 3x minus 12 equals 180. Add 12 to both sides of the equation, and you get 3x equals 192. Divide both sides by 3. 192 divided by 3 is 64. So x equals 64. Bazinga! Now, for the y's, we can use the same two parallel lines, but they're going to be cut by this transversal. But we have the same situation. Two parallel lines cut by a transversal, same side interior angles are supplementary. So 3y plus y plus 20 equals 180. So 3y plus y is 4y plus 20 equals 180. Subtract 20 from both sides of the equation. 4y equals 160. Divide both sides by 4, and y equals 40. Okay, so for part B, we want to find out what are the measures of the four angles in the figure. So, to get this angle, we would do, that's x minus 12, but x equals 64. So 64 minus 12 is 52. So this is 52 degrees. This is 2x for this angle, so 2 times 64 is 128. So this is 128. And we should check to make sure that those add up to 180. And they do. 180. Okay, so for this angle, the 3y angle, we're going to substitute 40 in for y. So 3 times 40 is 120. So this angle is 120 degrees. And then for this bottom right angle, y plus 20 is 40 plus 20, which is 60. And those two also add up to 180 degrees. So bada boom, bada bing, bada bang, bada boing, bada bingo. And just like that, we're done with that lesson. You know what to do. You know what to do.